Right, we need to draw these three inequalities on our axes. And first of all, we need to know where the straight lines are. So we're going to first of all draw the straight line where 3x plus 2y is equal to 18. And the easiest way to do that, rather than using gradient and intercept, is to find where this line cuts the axes. So first of all, I'm going to say when x is equal to 0, well, if x is equal to 0, then this has disappeared, and I'm left with 2y is equal to 18, so y has to be 9. So this graph goes through 0, 9, which is there. I'm then going to say, okay, if y is equal to 0, what will x be? Well, if y is equal to 0, then 2y will also be 0. So this is gone. I'm left with 3x is equal to 18, which means that x is equal to 6. So this line also goes through this point here, which is 6, 0. And I'm just going to draw that as a straight line from there to there. Now I need to decide which side of the line I'm going to shade, and the way I'm going to do that is, in this case it's fairly obvious, I need 3x plus 2y to be less than 18, so this is the side that I require, so I'm going to shade out. Remember the question says shade the side of the line which is not required, so I'm going to shade over here. Okay, next thing I need to do is y is less than or equal to 3x, so I need to draw the line where y is equal to 3x. Now the easiest way to do this one is probably to be using gradient and intercept. I can see that when x is 0, y is actually going to be 0. So what I have here is a line that goes through 0, 0, and its gradient is going to be 3, which means I'm going to go 1 across for every 3 squares up. So it's going to go through 1, 3, then it's going to go through 2, 6, and so on. I don't really need to go any further, so let's join those up with a straight line, and there is my line. And the side that I want there is not perhaps quite so obvious, so a good way of actually working out which side of the line we need, let's test a point. So for example, I'm going to choose this point here to decide which side of this line I want. So this is the point 3, 2, so I'm going to test the point 3, 2 by putting it into this inequality. So y is 2, and the inequality that I'm looking for is this one, and then 3x, well that's 3 times 3 is 9, and I'm going to ask myself whether or not that's true. Well, it is true because 9 is actually bigger than 2, so this is the side of the line that I want, so the side that I'm going to shade is everything over here. Okay, now the last inequality that I have to show on the graph is y is greater than or equal to 0. Well, this is the x-axis, but remember it's also the line at y equals 0. I want where y is greater than or equal to 0, so I want the part which is above the line, which means I can shade out all of this. So my feasible region is all of this. Let's just rub out that little dot. Okay, next step. Okay, we're now looking at part 2, and part 2 says that we are to find the maximum value of x plus 2y. Now, we could test the two corners, because usually what you're going to find is that the values of x and y that you want are in the corners. But what I'm going to use is I'm going to use a line, and I'm going to use x plus 2y, and I can put that equal to anything I like, which is convenient. So I'm going to put that equal to 6 and find the line x plus 2y is equal to 6. I then know that my maximum line is going to be something parallel to that. So in the same way as I did up here, if x is equal to 0 in this equation, then 2y is 6, which means that y would have to be 3. And if y is 0, this is gone, x is equal to 6. So the line that I'm looking for, and I'll just do that in a different colour so it's a bit more obvious. Let's just do it in red. Okay, the line I'm looking for goes through 0, 3 and 6, 0, so it looks like that. Now what I'm going to do now, and you can just do this with your ruler, is I'm going to just take that line and I'm going to slide it up, keeping it parallel. Okay, so starting from there, you can do this by drawing or you can just use your ruler. Okay, so I know if I'm minimizing, I'll go down to this corner, but I'm trying to maximize the value of x plus 2y. I go as far away as I can from, or as far to the right as I can possibly get away from the origin, and I can see that the place that I'm looking for is going to be just here. So this is the point that represents the value of x and y, which is going to give me the maximum possible value of x plus 2y. Now the coordinates of this point are 2, 6, and if I put 2, 6 into this, if x plus 2y, so I'm looking for the largest possible value of x plus 2y, well x is 2, and y is going to be, y is 6, so I do 2 times 6, it's 2 plus 2 lots of 6, well that's 2 plus 12, which is 14. So the maximum value of x plus 2y is going to be 40.